Hello guys, I'm Sandip. I'm physics faculty at and today we are going to start a new chapter uh, which is called as light. Okay. So tell me something about light. Okay. So what I can say, just give me one answer, right? Logically, just think on that and try to answer the question that if I want to see any object, what I do need? Simple human eyes, right? Eyes, we need the eye to see the objects. That's very clear and very basic answer we can say, right? So yes, with eye we can see every object. Good. So now consider this situation. You're sitting in your hall watching some television, right? And it's a night time, right? It's a night time, and suddenly the light is gone. Power cut is there, right? What will happen? There will be dark everywhere. You have your human eyes. That's good. Can you see the object now? You cannot see the objects, right? So, can I say that human only having eyes is not the condition to see the object? We need one more thing. What is that? That is light. Okay. So, this is the light, and because of the light, actually, we can see the objects, right? Answer me one more thing that can we see the light? Right? There's bulb or tube light, right, in front of you, right? So we can see the light, right? No, again, no, right? We cannot see the light. We can see the object which are actually reflecting the light. Okay, so remember this thing. We cannot actually see the light, but we can see the objects because of the light, right? So you will say that yes, we can see some bulb there. Bulb is not the light. Tube is not the light. Tube is the source of the light, and it is emitting the light. It is giving the light. Then only we can see some light there. Okay, like that. So these are some basic concept of the light, that how we can see the objects and whether we can see the light, right? So obviously we cannot see the light. Okay, chalo. So in today's lecture, we are going to cover this types topics we can say. First one is obviously the light. What is light? Then the rectilinear propagation of light. So what is the meaning of rectilinear? Simple. Tell me though. What is the simple meaning? Simple word. What is the word rectilinear means? It has some linear word. Now linear is, I think everybody know what is linear, right? Linear means one line. Yes. So rectilinear propagation. Propagation means going, right? Light is going. Therefore, we can call it as propagation. So light is going in a straight line. That we can say yes. That is our rectilinear propagation. So light travels in a straight line only. Okay. Good. Then laws of reflection. What is reflection? Right. So this is a very basic concept actually. When we woke up in the morning, right, we go to the our mirror, right, plain mirror, right, to fix our hairs, right, with the comb. That mirror is what? Mirror is actually showing your reflection there, using all the properties of light and that mirror, right? Obviously, we can say that we need the light, right, to see in the mirror. You cannot see in the mirror even in the dark with the help of your eyes. No, we also need eyes. Obviously, eyes is the most thing, and light is, we also need the light. That's right. Then formation of the image, how the image gets formed in our mirror. We can see ourselves in the mirror, right? How we can actually see there, right? We are going to see that one. Then the characteristics of the image. So those images which are formed by the mirror, what are the characteristics? Simple thing you can see in the mirror. Consider if you put the left hand like this, right? What the mirror shows. Observe it very carefully, right? Observer will show the different thing than your left hand. What is that? We are going to see that. And lateral inversion, same thing, right? Left hand. It is going to give you the image of right hand actually. It is going to change. Right? We don't observe that actually. Simple thing you can see. You are watching at the mirror and your image is watching at you. So don't you think it's something opposition is there, opposite there? So those are some characteristics, or let's say lateral inversion. Okay, like that. So all these topics we are going to cover in detail today. Okay, sure. So let's start. So first thing first, what makes the things visible, or we can see the object? As we already discussed that we need the eye, and the second thing is light, right? So these two things are very important. Then only we can see the objects. So who can actually provide the light? Who can emit the light? The main source, very important source is our sun. We can say sun is the very important source of the light. But the problem is it only provides light in the daytime. Where it goes in the second night time, right? Does it switch on? Is it a lamp? No, right? We know that thing that the earth is moving around the sun. So we are getting what we are getting actually. That earth is the, we can say, back side of the earth will have the night, and when the other side will have the day. So obviously some countries have the daytime and some countries will have the night time at the same time, right? So like that. Okay, so yes, sun is our main source of the light. So look at any object, what is going to happen here? Let's see. So this is our object. Simple. So there is a light source, need not be a sun. In your home you can use our normal tube light also, right? At night time what we do, we use our light, right? Artificial light. You can use that source too. Torch you can use, mobile torch you can use, doesn't matter. Okay, so light is coming from this one to the object, any object. Now I think this is apple, right? So on this apple, right, falls on this apple, and this apple, what it does, it reflects this light towards where? Towards our eyes, right? And obviously in eye there are a lot of parts of the eye. There is a lens and there is retina, right? So all these things were there, and we get the sensation of light. So just consider if this is the oddly shaped object, consider like this, right? Light is coming from the source, could be sun, or we know it could be anything, right? So consider light comes like this. It is getting struck here at this point, at this point, at this point. But what about this ray? When this ray is coming, there is no object here, so it will pass like this. Similar to this one, I can say it will pass like this, right? So only part which is getting struck to that object, that part will reflect it. So this ray is not going to get reflect. So we cannot see this, where what is here, right? We cannot see this part, right? Simple thing. So only consider this outline. We can see the outline and all the inside of the sheet. We can see all those things, because that part is going to reflect your rays, right? Okay, so we get the sensation. Yes, this is the object shape, and whatever is the shape, we can accordingly get the sensation in our eye. Okay, so this is how we can actually see the objects. Then tell me about the colors, right? This apple has the red color. Many color objects are there. How we can see the colors then? So obviously, objects must have some property to absorb some colors and reflect some colors, obviously. And even our eyes also have properties to detect the color, which color rays there. Right? Now, when we say white color, even in this diagram also, in this image also, you cannot see the white light coming there. There are 7 colors actually. So in normal white light, when we say the light is coming, right, it is not only one color. There are 7 colors. So can I say this object must have some property that it will absorb all red color? Very simple, right? So apple absorbs all the colors and reflect. Let only red is reflected towards our light, right? So who decides which color is there in that light? Obviously 7 colors. We also know the name of the 7 colors. Which are those 7 colors? Vibgyor, right? V means violet. I means indigo. Then B means blue. G means green. Then we have Y. Y means yellow. So 5 are there. Then orange is there, red is there, right? So those are the 7 colors in our white color. And according to those, we can see the objects, right? So, so these colors are decided by the different wavelengths. Now, what is wavelength? Wavelength means what? This light actually is traveling. Light is traveling like this everywhere in terms of waves, right? And this two, you can say this is called as crest, right? Distance between these two, we can call it as wavelength. So colors, every color will have the different wavelength. Suppose this, I can say this is yellow color. Yellow color will look something like this. Red color have the more wavelength, so red color will look something like this. So when the white light comes from the sun, it is a mixture of all the colors. But object is going to separate those wavelength colors according to what? According to wavelengths, right? If we can see that this is the wavelength, then some wavelengths will be absorbed, some wavelengths will be reflected. So this is how we can actually see the colors also. Also in our also there are some sails. There are two types of sail actually: rod sail and there is another sail. And that rod sail actually are responsible for the color. Okay, so this is the basic theory why we can actually see the different objects. Right now, let's move to the next part. Rectilinear propagation of light means you say that light is traveling in what? In straight line. The light starts from the sun. Is it just moving in one direction? No. Sun is giving light to every part, right? Even our bulb. It's not like that light is only coming towards you, right? It is going in every direction, right? So if from the bulb or any source, light is going in every direction, how we can say it is rectilinear? Yes, it is going in every direction, but in straight line, like this. They are going in. They are not going to go bend like this. So consider from source, it goes like this, and then it goes here, then goes here, goes here. No, it is not going to happen. Right? We can bend those light, but we have to use the instruments there. Right? Which instrument we can use? If I want to bend this line, I can use the mirror here. Then it will get bent. Here also I can use the mirror. But if there is no other object in between, light is going to be straight line. Okay? It is not going to change its rectilinear propagation. This is a simple experiment you can see in the first diagram. What there is one source. This is a light source, right? Source of the light means candle. We are using the candle there, and that candle, because of that candle, light is going in the straight line. What this child has done, he has put the 3 screen like that, which have some holes in between, right? So light is going to straight line like this, right? Now assume that he blocks this hole, or he moved this portion, this board, like this here. So hole will be here. So light is coming from this hole, then it will get blocked here, right? Like this. So light, this proves actually that light propagates in the rectilinear propagation, or rectilinear line we can see in one line. Also, this girl is also watching this candle here. If this pipe is straight, yes, she can see the candle. If the pipe is bent, light is not going to pass like this, right? She will not see any light there, right? Okay. So this is the rectilinear propagation of light. Now, when we say the objects which actually can give some light, right? Those objects are called as luminous object. So what is luminous object? So tell me, consider candle. Is candle a luminous object? Yes, obviously it is producing the light, right? So every object which is producing the light, emitting the light, is the luminous object. Very simple. Tube, yes. Bulb, yes. Torch, yes. Nowadays we use the mobile phone for our torch, right? Yes, it is luminous object. What about the screen? Screen is also emitting some light, right? Not as powerful as bulb or torch, but yes, it is emitting some light. So it should be luminous. Screen of laptop I'm saying, or screen of mobile we are seeing, right? Yes, those are giving some light. So yes, those are luminous objects. What are the biggest source? As I said, sun. Sun is a luminous light, luminous source. We can say luminous object. There are many billions, trillions of stars in our sky, right? You can even look at the sky in the night time and you'll see a lot of stars. Those stars are the luminous object. What about the planet? Is Earth emitting the light? No, right? Earth is not emitting light. So Earth is not luminous object. It is non-luminous object, you can say. Okay. So we should also know what are the luminous and non-luminous object. Okay. Let's move next. Let's talk a little bit about the reflection of light. So when we say reflection of light, I told you that if you want to bend the light, what we can do, simple instrument, that is our plane mirror. You can put the plane mirror, right? Then that incident ray. Incident ray means what? Whatever ray is coming on the mirror, that will get bent like this, right? So simple. If you keep one mirror, there's nothing but our plane mirror. Draw one perpendicular like this. This perpendicular is called as 90 degree. Perpendicular means it is making 90 degree 90 degree angle here, and it is called as normal, right? Normal means anything perpendicular is called as normal. So consider if here is a source, our sun or torch or candle or anything. Because of that, one ray will come like this, right? It will struck here. And what is the job of this mirror? Mirror has some property. Property means actually that is a plain glass, but it has silvering. We do silvering. It is called as silvering, right? So once you do the silvering, that becomes the plane mirror, and that plane mirror is not letting this ray to pass like this. Right? We know the normal mirror. What does the normal mirror do? It let pass the light in straight line. So instead of mirror, if it is a plain glass, like our window, right? Yes, it will pass normally like this. Okay. But now, as this is the plane mirror, this silvering is done. It is not allowing this light to pass through it. Instead, it bends the light like this. Okay, like this. Okay. So who decides that angle through which it should bend? Right. So it's very simple to understand. Whatever angle this incident ray is making here with the normal, same angle is here. That reflected ray makes with the normal. Theta, theta. This is how that light is going to bend. Now remember, this concept is very important when we are going to plot the images. We want to find out the images of the mirror, how those images work. We are going to see these things, right? So this is important. What is important? The angle of the incident ray with the normal. Incident ray means what? Whatever ray the source is giving. The same angle, the reflected ray. Reflected ray means what? The mirror is bending that incident ray, obviously. That is called as reflected ray. The reflected ray makes the same angle to the normal. Okay. So this is the reflection of light, and it also has two laws which we should remember. So let's say laws of reflection. So what I can say? First law. There are three things here I can see. One is the incident ray, second is the reflected ray, and third one is the normal. So let me write those. Incident ray, reflected ray, and normal. Now where is the normal? Normal means what? Normal drawn perpendicular to the mirror. So when we say perpendicular to the mirror, I can draw normal anywhere here. It could be normal, this could be normal, this could be normal. So which normal we are talking about, right? So we have to explain that too, right? So incident ray, reflected ray, and normal drawn perpendicular to the mirror at the point of incidence. What is the meaning of point of incidence? This incident ray is meeting the mirror at this point, right? So this becomes the point of incidence. So draw the perpendicular to the mirror through that point. That we are going to call it normal, right? Particular normal at the point of incidence. So all those three things lie lies in same plane. So remember, this is our first law of reflection. Simple. Okay. Now second law says that angle made by incident ray to normal. Incident ray is making angle with whom? With normal, obviously. Is equal to what? Is equal to other angle. Which angle? Angle made by whom? Made by reflected ray with normal. Instead of 2, let's write with here, right? With normal. So theta. Can I say theta is equal to theta? Or sometimes it is also say I is equal to. These are the laws of reflection, which are obviously going to be important for our images purpose. Okay. So once you know this law, you can find out the image of any object using this mirror. So where the image will appear, right? We are going to see that anyway. Next slide. Okay. Sure. So next we have image formation of mirror. So I told you that if you know these laws, second law is very important, that theta is very important actually, right? Theta is same, then only we can find out the image. So let's see how the image is formed of the object. Now this is the plane mirror. Plane mirror means obviously this is the silvering part, we can say, right? So this is the reflective part. So if you want to see in the mirror, obviously we have to stand in front of the mirror, right? Reflective. So now this is object. So how to find where will be the image? So what? Very simple thing. Draw one line. Now here we can see a lot of lines are drawn, right? Draw one line like this, right? It meets here. What we want to draw here? Let's draw one normal. Whatever angle it makes here, find out the angle, measure the angle, and draw the similar angle here. Okay. So reflected ray, we will get the reflected ray. Once we got the reflected ray, right? Let's try another ray. So this is the second ray, draw the another normal here. This is the angle, make the same angle, you'll get the reflected ray like this, right? This is the another one, right? Angle should be same. This is the only concept. Once we got all the rays like this, right? What we have to do, whatever those rays are, just extend them behind the mirror like this. Simple. Once you extend them like this, right, they will meet at one particular point, and that particular point is nothing but image. So this is how image is formed. We need the observer here, right? You're watching from here. This is the eye of your eye, you can say. Object is here. Then you will see the image at this side. Okay. So this is how we can say the image is formed on the plane mirror. Also consider this another animation is there. Very nice animation is there, right? It also shows us how the image is formed, right? If you move the object, where the image will move. Again, you can see you have to draw two rays, one or two rays, and every position, every point you can see. Consider the object is here. You can see this is, you can draw the normal, and these two angles will be similar, right? Every point. Okay. Again, try this one. So yes, this is the normal. It bring the object at the one particular position, and we will try that. Okay. So consider, yeah, this is the normal, this is the angle, this is the angle, right? You can see those things. So draw the normal, same angles, it will be, you can easily find out. Okay. Now consider this is the plane mirror. I'm keeping it like this, okay? And you are looking into the mirror, right? Consider you are looking like this into the mirror. This is your eye, right? I want to see the image of your foot, right? Let's try this one. So consider this is the, we consider this is the object, right? And we draw the rays there, and we know how to, where will be the image will form. Now, how you can actually see the foot? Consider, for that we need to draw something like this. Image will, ray, incident ray will be like this. Let's draw the normal. This is the theta, and up to the eye, making the same theta, we are getting this. Let me draw it a little bit lower. Okay. So let's take it outward here. Yes. So what you can see, the foot of your image will be here. Simple. Similarly, every point on your body is going to make rays like this, and it is going to meet like this. Again, it will go here, right? It will go here, then it will go here, and put the point. So you can see, or the plane mirror points are exactly opposite here. So then only you can see that your reflection exactly as you, right? Now I may not be able to draw the exact replica of this man here. Let me try this one, okay? So you'll get something like this. Right, so you'll get the exact replica there. So this is how the plane mirror actually, every point you can see, even consider the top of your head. If you consider the top of your head, it will, let's say light passes through here, make the incident angle here, very small incident, draw the normal, then there will be two small angles, and then you can see that this will become your head stop, right? Okay, so this is how actually the image gets formed by the plane mirrors. Very interesting thing, right? Okay, good. So let's move to the next part. So this characteristics of the image. So whatever is formed, we have seen in the three different diagrams there. Okay? The very simple thing to understand is wherever that ray is going, just find the normal, find out the incident angle and reflected angle, and draw the, extend that reflected angle, right? We have to extend that reflected angle. Then only we can get the image. Even in all the three cases, you can see that angles are extended like this. Then you are getting the image of that particular point. Obviously, any object is made up of different points, as we have seen in this case, right? That we can consider foot as one object, hand as one object. Get the image of all those objects at the accurate places, very accurate places. Then only we can get the full image of the ourselves there, right? Like that. Okay. So, what are the different properties of those images? So, we already know how to form the image now. So, characteristic of image, let's say on plane mirror. Let me add one more word here. On plane mirror. Okay. So characteristics says that first of all it is virtual and erect. Right. So the image is virtual and erect. What is the meaning of that? So virtual means what? For any mirror. So if this is the mirror, there are two sides. This is called as real side. And this is called as virtual side. Real means obviously easily you can understand whatever you see in the mirror, that is not the real world, right? That is the, you only see it as a reflection. When you see your own reflection, there is no another person like your twin or etc., right? It is not real. So we are going to call that as virtual, right? So image by the plane mirror is virtual. Erect means what? Erect means simple. If you are standing upside or like this on your legs, image also standing on leg. It does not, it never happens that you becomes inverted, right? So erect means same side, upright we can say, or upside we can say, right? Okay. So there is, right. Then behind the mirror, obviously the image is going to go behind the mirror. You cannot touch that your image there, right? Simple. Size of the image is equal to size of the object. So whatever height you have, your image will also have the same height. It is not going to change, right? So Simple. Otherwise, plane mirror wouldn't have worked. If your height is, let's say, 5 feet and mirror shows, let's say, 10 feet or half, that is 2.5 feet, it is not going to work, right? You will need the exact height of yours. So then only you can comb your ears, right? Very simple. Right? Then you have the laterally inverted image. Laterally inverted image means, I told you initially, if your left hand in your image will look as a right hand. Look that very observe that actually in mirror. Right? According his point of view, his means what? Your reflections point of view. Let's call it your twin, right? Your twin is in mirror, and according to the point of view of your mirror, if it's your right hand, he will say it. No, it's my left hand, right? Like that. That is called as laterally inverted image. So we have seen that image doesn't get inverted; it is erect, it is upright. But there is a lateral inversion, means left becomes right, right becomes left. Okay. Then distance of image behind the mirror as same as the distance of the object in front of the mirror. So very simple. If you stand, let's say, if this is your floor, right? If this is floor, right? And you are standing at the 2 units distance. These are tiles, right? You are standing on 2 tiles. Right? Your reflection will also stand on 2 tiles only. Right? So this is the reflection. Your twin, right? We are saying your twin. It's not actually your twin, but let's say your image is your twin. Your twin is also standing on here. If you move closer here, let's say you move here, your twin also move here, moves, your image will also move here. If you move further away or away, right? Then your image will also move away and away and away. Right? Very simple to understand. So those are some properties of the image on the plane mirror. Right? Okay, so what are the properties? First one is the image is virtual. Virtual means it is not real. It's not in our real world. And it is erect means upright. Behind the mirror. It is behind the mirror, not in your side, right? Then the size is also same. Size is not going to change. Then laterally inverted image means left hand becomes right hand, right? Due to the view of your image, we can say. And the distance is also same. Wherever you are standing, your image will also stand there. Okay, simple. Now let's study this lateral inversion. So, whenever ambulance goes nearby, whenever you are traveling anywhere on bicycle or bike, in car, right? Whenever the ambulance goes, observe this thing. If you look at the front, on the front of the ambulance is spelled like this. You cannot read this one, right? Because it is inverted. Inverted means actually it is laterally inverted. Why it is like that? Why they are not writing ambulance in normal fashion? When we use the name on our car, something like that, right? Your name, you put your name on the car. You don't put it laterally inverted, right? You put it in normal. You can read it on your car. But why the ambulance is looking like this? The answer is in the second image. Right? So ambulance are the emergency services, right? They have that siren also, right? That start sounding, right? Right. So what you do when the ambulance comes, you give the base to the ambulance, right? So never do that, right? Never raise the ambulance that I want to go ahead. No. Give some space to the ambulance so that ambulance could go ahead because it is the emergency service, right? So is people should obviously give some weights to the ambulance, and when actually you are looking in the mirror that from behind the ambulance is coming, right? Then you should easily understood that yes, it is not normal car. It is ambulance. It is emergency services. We should give it away, right? So in mirror, you should look it clearly. Ambulance, right? Why it is happening? Because there is one property we have studied this one. What was the property? That mirror is inverting the image, right? Lateral inversion. I'm saying lateral inversion. Right becomes left, left becomes right. Similarly, if this letters are like this, they are going to get laterally inverted, right? So in mirror, you are going to see the exact ambulance word as it should be, right? And that is the reason of the ambulance. So whenever you're going, whenever you will see the ambulance, just observe this thing, that ambulance is not written in or straightforward words, but it is written like this. Okay. Next. Yes, here also you can see one example of the lateral inversion. That right hand, you can see the right hand as left hand of the image, right? You can also try this anytime at your home. Also, we have the mirrors at home, right? You can consider this one too. Then, so this is the whole part of the part of our introduction of light chapter. So what we have seen, we have seen that how we can see the objects, luminous and non-luminous sources of the lights are there, right? Before going to the questions, tell me one thing. Yes, at the daytime you can see the sun, right? You get the light from the sun. That's right. So I can say yes, sun is the source of the light, luminous object. It is the luminous object. This is the daytime. At night time, you can see the moon. Moon is giving the light, right? So can I say moon is the luminous object? Right? Moon is giving the light, so it should be luminous, right? No. Remember, what happened actually, when Earth is in between sun and moon, Earth should be smaller than sun, right? And moon should even be smaller, right? Like this. Let me show the moon like this here. So this is the moon, very small, smaller than Earth. Earth is smaller than sun. We know that part. Okay. So let me go back to the. We have some nice image here. Yes. So this is sun and Earth. Yes, we can see this one. So this is the sun, Earth. Again, I cannot see the full image. Consider this is sun. This is our Earth, and the moon is here, right? Moon is also spherical. We know that. So let's draw like this. Normally, in the daytime, we get the sun lights directly from sun. We cannot even see the moon that time. What happens nighttime? So this is the daytime for the Earth, and this is the night time, right? And in night time, this moon is giving some rays, light we can say. So how it is happening? Is the light, is the moon a luminous object? No. Then how it can give the light? It is not giving you the light. It is actually, this moon is getting the light from the sun. The sun is transmitting the light to everybody. It's not like that only Earth is favorite of the sun. So let's give the light to Earth only. No. Sun is giving light to everybody, every planet, every object that comes in the sun's way. Right? So moon is actually getting the light from the sun, and now the moon is going to transfer this light towards the Earth, towards the night part, we can say. So people on living on the night part, half day we live on the night part, and half day we live in the day part, right? We know that part. So for the night time, we are getting the light from the moon. That is actually the light from the sun only, right? But it is reflected from the Earth, right? So this is how actually we get the light. Okay. Sure. Let's move to the. Yes, so we have seen this. How we can see the object, obviously, because of the eye is the most important thing, and obviously light is also there, right? So using the light and eye, we can see the right. Then we have also seen that the light travels in what? Only straight line. It does not bend, right? If you want to bend it, either use any object in between it. But if you use the object, it will not bend. You have to use the mirror. Mirror will reflect that, right? So even in this case, consider this girl cannot see the object, but assume if you put some mirror here, what will happen? Light from the candle will go here, and yes, now she can see the object. And if you put the mirror, obviously we can put the mirror everywhere, and we can see the different objects which we normally cannot see, right? Like that. Okay. So simple. Then when we say the reflection of light, two laws are very important. All the incident reflected and normalized on the same plane. Right? That is the first law. And the second law is important, that angle of incidence and angle of reflected ray should be same. And that is the how the image will be formed from the object. What we have to do? Find out the incident rays from the source and give it to the objects. Uh, give it to the eyes. We can reflect towards the eyes, and then we can just extend that reflected ray to get the object like this. Okay. So even sun can also, we can, if you put the mirror, you can also see the sun. Sun's light is coming like this. Mirror will reflect it and extend that light behind the mirror. And behind the mirror, you are going to find the sun or image of the sun. We can say, right? That's very easy to understand. But never look that into the mirror sun, because sun has a very powerful intensity, right? It could be harmful for our eyes. So try not to look at the sun directly, or try not even to look at the image, right, of the sun. Right? We can look at the moon directly, because moon's light is not its own light. We have already seen that, right? It is just the light coming from the sun towards the earth and reflected by the moon. Very simple. You can directly look at the moon, right? But to look at the sun, it is very difficult. Okay. Then we also seen how the image is formed. Obviously, it is based on what? Second law of reflection, that the two angles are same. According to that, we can see this image. And the characteristics are also important, because this characteristic decides the image, right? How the image should look like. Characteristic is erect. It says upright. Therefore, we can see the upright image of ourselves. And the size also matters. Size should not differ, right? Okay. There are some spheres which can actually change the size also. Right? We are going to talk those in the next session. Right? Don't worry about that right now. Just remember right now. Therefore, I have added here the plane mirror. Plane mirror gives you the same size, but other mirrors are not like that. There are some types of mirror which have different properties. They are going to give you the different images, different size of image. Yes, you are going to get long, you are going to get short, or fat also. Right? How that will happen? We are going to see that in the next session. Okay. Then lateral inversion, we have studied about the ambulance, why the lateral inversion is necessary like that. Okay. And the right hand becomes left hand, and etc. etc. We know that part. Chalo. So this is a whole theory part. Let's see these questions here. Particular questions. A smooth shining surface which rebounds the light back in the same or different direction is called as, very simple. We were studying about the mirror. So what is lens? Lens is what? Lens is consider glass material. Now consider the specs. The specs has some lens in that, right? Is it a simple glass or something different? Obviously, simple glass will not change my vision, no? Like window is not going to zoom objects for me or make it clearer. Why I use the specs? Why you use the specs? To see the objects clearer, right? So lens means we use the lens in the spectacles, and they are going to change the properties, right? How the lenses work or specs works, we are going to see it in the upcoming sessions, right? Then reflection of light is not the object, obviously. Point of incidence is also not the object, right? So mirror is our answer. Next, beam of light striking the reflecting surface, right? For reflecting surface means mirror. One is striking like this, and one is going away. What we call the beam which is striking? That is incident ray, right? Let's mark this incident ray. Reflected ray means what? Which is going reflected. Normal means what? Which is making 90-degree angle. Right? Reflecting ray. What is refracted ray? Refracted ray is again the new term. So we talked about the mirror in this session. In upcoming sessions, we are going to talk about the lenses or glass material. In that case, this is the incident light, and instead of going like this, some rays will go like this inside the material, right? That is called as refracted ray. Okay, so we are going to see this in the upcoming session. In case of reflection of light, angle of incidence and angle of reflection are related as, we know this part, angle, both angles are equal. It's very easy to understand, right? So I is equal to R. Easy answer. Good. Sure. So this is the whole theory part of the first session. We have studied about the some introductory part of the light. In upcoming sessions, yes, we are going to study about the images, and as I told you that there are some mirrors which are going to change our sizes, which are going to make us tall or short or fat also, right? Like that. So we are going to see those things and how those things works. We will also see some lenses, how they works, why I'm using the spectacles, why you are using the spectacles, right? So we are going to see those things. Okay. So I hope you enjoyed the session, and so if you do have any queries, just put them on forum so I can answer to them. Okay, sure. So thank you very much. Have a nice day.